Good morning. This lesson is for my Integrated 1 class, but before I get started, I want to say I hope that everyone's doing all right out there. I'm not sure how I'm going to title this lesson, but I'll tell that when I title it in the title. But what I am sure of are our 4 goals for today. Our first goal is going to be to review translations. Our second goal is going to be to discuss what rigid motions imply. Our third goal is going to be an example of using a vector to translate. And our fourth goal is going to be to summarize what this lesson was about. Go back and revisit all the ideas. All right, so let's go ahead and jump into our first goal, and that's to review translations. A translation is a rigid motion that slides a figure from one location to another. The orientation of the figure does not change as it is translated. So what I'm saying with this last sentence, the orientation, that means that it doesn't spin or flip. It stays in the same direction as it slides. So I feel like I'm TikTok dancing. As my hand goes up, the orientation is not changing, it's translating, right? So that just means it doesn't spin. You might want to note that. Here's an example of a translation. And again, notice that the triangles didn't spin, they just slid, right? Okay, so we call triangle ABC, this guy, triangle ABC, we call this the pre-image, and we translated it, which means it slid and it didn't spin or rotate, to triangle A prime, B prime, C prime, right? This is A prime, B prime, and C prime. Triangle A prime, B prime, C prime is the image. Shapes with prime marks are the result of a transformation. Remember, transformation is some type of movement. We start with a pre-image and we end with the image. This is my pre-image, this is my image. I'm going to add that to this. This is the image. And pre-image, there we go, and that's my image. Okay, I can do this. All right. Translations are sometimes given to us with a rule that tells us how far left or right and up or down to translate the figure. Rules can be written as a vector or in component form. This is what we're going to discuss in the next lesson, how these rules can be told to us and how to move using a rule. So this lesson is just more of a review. All right. So let me go ahead and clean all of this up, and I'll be back. I'm back. So let's go ahead and jump into our second goal, and that's to discuss what rigid motions imply. So let's talk about rigid motions. Rigid motions are transformations that do not change the size or shape of the figure. There are 3 rigid motions: translations, rotations, and reflections. Today our lesson is only about translations. We'll have separate lessons about rotations and reflections. Remember, the definition of congruence, or this is a symbol for congruence, is that congruent figures are the same shape and size. Since rigid motions do not change the size and the shape of a figure, we can conclude that the pre-image and the image must be congruent figures. The pre-image and the image are the same size and shape. That's why they're congruent. Okay? So what this implies is the image and the pre-image are the same size, same shape. That's very important. Okay? It does not change the size or the shape. Here's my pre-image. There's my image. I know that this is where I moved to because I have the prime marks. There was a translation in this direction. So what I could say is I could say that triangle RST is congruent to triangle R prime, S prime, T prime. They're the same shape and the same size, but they're in different locations. All right? So hopefully you get the fact that what rigid motions imply, which are translations for this lesson, is that the pre-image and the image are the same size, same shape. Let me clean all this up. We're going to watch an example of using a vector to translate, and then I'm going to come back and talk about summarize this whole lesson. So I'll be back. All right, so you can see my hands, not my face, on my hand model now. All right, so what I'm going to try and do, I'm going to try my best to do this, and hopefully this makes sense to this little lesson I'm going to make. Do my hands really look like that? Anyways, for this lesson, you're going to need a piece of paper that you fold in half, and you're going to need a blank piece of paper. We don't need a ruler. I'm watching my hands as I talk. We don't need a ruler. We need a pencil, a piece of paper, and a piece of paper folded in half. So the first thing I want you to do is I want you to take this paper and I want you to just use it as a straight edge. So we're just going to draw a triangle. Okay, we're going to draw a triangle here. Guaranteeing that this triangle is a nice, has nice straight sides. There's my triangle. All right, and I'm going to draw what's called a vector, which is going to be a random length, and I'm going to put it in, just slightly above my triangle. This is my vector V, and it's telling me that I want to move my triangle in this direction this far. And I'm hoping you can see the pencil. I really am. All right, so let me label this triangle. This is triangle A, B, C. All right, so here's how we're going to translate, which means to slide or push the triangle, using our folded piece of paper. So the first thing I want you to do is I want you to make a mark that represents how long. That's not very good. It's a good thing I'm not a construction guy, because my building would be off. I'd like you to make a mark that shows how long your vector is. Okay, maybe I need to make that a little bit darker. But this is how long our vector is. Now this is going to be the part that's a little tricky, and you need to try your best to do this, is we want to make parallel lines to our vector, where one side matches up to a vertex on the triangle, and the other side, making sure these are parallel, the other side is where we translate to. So this is now B prime. Let me try and do this with A. Does that look parallel? That looks parallel. That's my A prime. You know, it might be smart to draw some dashed lines, because it'll make it easier to see the parallel down the way. I hope I'm having a good hair day, if you can see my hair, top of my head. Okay, those are looking pretty parallel. And now I gotta do one more, and that's vertex C, and I'm gonna try my best to make sure these are all parallel. That's looking pretty close. This is gonna be off, by the way, which is okay. As long as it's close, I'm happy. As long as it's close, I'm happy. Oh. Dash lines, dash, dash, dash. And again, notice I use the same distance for all of these. So there's my C prime. Okay, and I'm just going to now connect my new translated vertices to represent my image. Now, I have no problem if you use a ruler. The only reason why I'm not using a ruler is I can't assume that everyone has a ruler, and and this will make do with what we got, and I think that's fine. Okay, let's see here. Oh, come on, I can do this. Okay, so you can see that I have, in fact, translated my triangle ABC along this vector, and my triangle ABC, that was my pre-image, and I've slid it in this direction, and this is now my image. And so this is one of the things that I want you guys to be able to do, is I want you to be able to do this with shapes. So I hope that this makes sense to you guys. I'm going to try not to talk as much with my hands as I am, but I hope that this makes sense to you. And I will wrap this lesson up. And I don't know how to end this because I'm not looking at the camera. I'm looking at it in front of me. So let me set up the whiteboard and I'll be back. I'm back for the last time, I promise. So let's go over the fourth goal, which is just a summary of this lesson. Translation, slide a figure to another location. We start with a pre-image and we end with an image. Prime marks indicate the image. Translations are rigid motions which make congruent figures. Alright, so hopefully you understand how to translate an object using a vector. And we're going to be doing an assignment that's just you translating an object like I gave an example of. So I'm going to go ahead and end this lesson here. Again, I hope everyone is doing all right out there. Have a great day, everybody. Bye-bye.